Greetings and welcome back to my channel. Welcome back to second part of the turnover of this magnificent relic of the past, CLEARTONE analog mobile phone. So in this part we'll pull out the macro lens and take some nice close-up of the parts and individual boards, and we'll see what's on there. And here is the first board, first of the two that first came off of everything. And here we have a can with an adjustment port NJC3096B, 12.8 MHz, is probably some kind of oscillator. Now a quick look on Google didn't bring any part. It doesn't help that the NJC3096B actually follows the pattern of a registration plate, which then takes you to all sorts of weird websites that are completely off subject. And we've got a UCF 933S4, which is some sort of filter. It's got a plastic sticker on top of it, and we'll take that off in a moment. Another filter, we've got a Sony part, Sony A1003B. What I think this is a CX-A1003B, which appears to be low power FM IF amplifier, so intermediate frequency amplifier, which is doing some amplification. And we've got MQC512 from Murata, which is a VCO, so it's a voltage controlled oscillator. So this gets some sort of input either from one of the processors or some analog circuit. Depending on that, outputs a different frequency. There are a few passives and a few adjustment ports, actually quite a lot of adjustment ports. Here is a little daughter board on top of here, which I can pry off. And underneath we've got a couple of parts, 501SL8940, that's a date code, 1989, and again 1989, 87001A, but those two unfortunately do not bring immediately a data sheet on. Okay, so this board is connected. Actually, the little daughter board is just a few discrete components. On the back of it we've got an IC, and this does have a datasheet. It's a PLL frequency synthesizer, so phase locked loop frequency synthesizer. It's interesting, on the board there is a cutout that looks like a bit of an afterthought on the actual board. I've bent a few pins already. I think that's just now when I was pulling it out. This board is been sandwiched with and connected with those two wires. Now those are relatively thick wires. Those are actually coax wires going onto this board. And here you can see the little strings that are meant to make it easier and easier to pull apart. Again, made in Japan, JRC, Japan Radio Corp, made by JRC, and then fitted and to a phone that had some sort of obscure brand, or maybe it was a big brand back in that day when this was out, but I don't know. What you see right now on the screen, this rectangle, has got this little shielding, and that was mating with this bit here, and that basically formed a RF can, so there was no interference getting in or out of that area. This is the battery contact here. The battery contact from here goes here to a component with a bent leg that goes through the PCB. It's soldered out like that, so I don't know, they've even got a via on here in the mounting hole, as you can see. So clearly via probably wasn't enough current capacity for what this was drawing, so they had to put a thick wire and blob solder it. Now on the other side of this board we've got an amazing amount of filters, and they're all dielectric filters from what I could figure out after googling this long part number, or maybe this one. And yes, I know nothing about them. As far as I'm concerned, I do not understand why those things work at all. Here are the coax cables coming into places. Let me take one apart and show you what those look like. So here I've peeled off the plastic covering from it, and this is what a filter like this looks like. So it's a ceramic, very hard ceramic material. It's quite brittle, and there are just a bunch of holes inside, and it seems like it's coated with some sort of conductive material, and in some of the holes there are connectors to which the signal is being fed to through legs that are soldered underneath, and that's it. So it's just a shape of a ceramic with holes inside, and for some reason this provides some filtering, and I have no idea why. And here's another one, and that's the same thing, that's the same thing. And this scan will look at, that's something else. Here is that weird part that I mentioned in part 1, IRFD9123. As you can see, the part has got, oh, it's a 3-leg item, so let's try to Google that. Avalanche energy rated P-channel power MOSFET. That is a mouthful, so it will do 1 amp and 60 volt, no, 0.8 amp and 100 volts actually, RDS, so resistance drain source at fully switched on states is 0.8 of an ohm, which for a P-channel MOSFET is not too bad actually. But the interesting bit is the package, which I've not seen before, where 2 legs are bridged on the outside of the case. And here we've got a bunch of electrolytic caps and this Japan module brick, which I think may require some screwdriver access. Okay, no, the part on here on top appears to be just plastic that does come off, but it won't come off because the caps are in place. There are only 1, 2, 3, 4, 5, 6, 7 connectors going onto it. Let's first try to Google that. So from what I'm gathering on here, I found a datasheet for a part number ending in 20, not 16 like this one. And what this appears to be, the datasheet is all in Japanese I think, UHF 1 watt, so it's probably an amplifier. So it's an amplifier module that will show work on the desired frequency range that this was operating. And here it is. I've taken it out of the board, and if we take the top cover off, check this out. So here is some high frequency stuff happening, definitely. Look at all those tracks. This is beautiful. So let's maybe try to zoom in. This is probably as best as I can get. So yeah, there we go. The little cross in the middle of the screen right now, that's most definitely some sort of amplifier transistor in there. It's a hybrid module, and you've got little tracks that have got specific shape in order to accommodate and provide functions of either capacitor or a inductor. This coil is interesting. So as you can see right here, this just creates a loop, then it coils off over here. So this loop, I don't know, I'm guessing is possibly acting as a capacitor, and this would be a coil, so it would be LC circuit over here on the PCB, and a few more snaky things, and yeah, that's what it was. So that's how a hybrid RF amplifier module looks like inside. I forgot to mention, over here we've got 2 parts which are clearly different. They are physically different size, those 2 blue things, but they've got the same markings, 55C1, and the same manufacturer. So yeah, go figure. There are 2 little TDK cans like this on this board, one here and one here, just upright. So let's open one of them and see what's inside. So here it is, and I've applied some excessive force to take this off, and the top does actually come off. And inside we've got this weird arrangement. There is a ferrite cap on top, which seems is connected to the outer shell, and inside is this strange arrangement, metal dome. And what we've got in there, underneath the copper, is another ferrite and a few tracks again with what it seems very specific shape. It's very nicely three-way symmetrical. I'm sure this stuff was not cheap, but there isn't much in it. here is the third board. This is the board that has got the main proprietary connector and the antenna connector and all the other antenna connectors attached to it. And we've got a big Oki chip, M74017. This is demodulator for high frequency. And another Oki device, something with a sticker on it, a Mitsubishi part 82C55A FP2. And a quick look on this, this seems to be programmable interface for something, possibly. You can see 2 rows of solder pins on here, and that interfaces to what's on the other side, which is the EEPROM with a sticker over the window. The quartz glass window. We can take the sticker off, and there we go. Here is a beautiful chip inside. You can see all the bond wires. It's a shame you don't see those very often anymore. Those were just really pretty chips, and you've got an exposed die that you can look into really deep if you wanted to. Let's see how far can we go. And here I'm going to try to freehand a good shot of what's inside that window. So you can see the bond wires going onto a little substrate, and yeah, there's the piece of silicon on the. There are a few other supporting devices to the actual chip. And all the bond wires fanning out. Here is a visible structure in the middle. This looks like some sort of drivers for the memory. And yeah, that's how it looks like. So this is what was available to use before the E2PROM, electrically erasable memory. Those were, in order to erase this type of memory, this was the only multi-write chip some time ago. So you'd have to expose them to UV light in a special oven, or leave them on a windowsill for quite some time, and then it would get erased if there was enough sunshine. Okay, fueled by curiosity, I've vandalized this can to see what's inside, and not much. It's just a ceramic substrate with what looks like standard crystal oscillator and supporting circuitry, including a trimmer for fine-tuning the frequency, and that's about it. So they just packed it into a nice little module for convenience. So I think the more interesting can is this one. I wonder inside a VCO what's going to be in. And here it is, MQC512 Murata. Hacksawed it all the way around to get into it. And the case is relatively thick actually. It's about just under 1 millimeter thick, so quite a bit. And here it is inside, so it's a little ceramic module. On this one there isn't a regular crystal oscillator, but there is this cavity in here which has been tuned to a certain frequency, I guess. Again, this is the stuff I do not particularly understand, but it is amazing what people came up with over the years. There is 2 transistors in here, 1 diode, and the rest of it is passive. Again, there is 1 small coil on the actual substrate, but that's about it. So that's your VCO, voltage controlled oscillator. So I think that's it for macro shots. Disappointingly, it didn't turn out that much exciting. At least I was expecting a little bit more of some weird wizardry happening, but I guess old analog phones were simple and there wasn't much in there compared to a modern device. So that's about it for this video. Hope you enjoyed it, and subscribe for more random electronics related stuff, teardowns full of destruction or builds or some other miscellaneous stuff. But as far as this one, that's it. So thank you very much for watching and take care.